Hello, this is the last part 5 of your test preparation. Hopefully you're feeling like a math expert by now. Let's get ready. We're going to simplify square root expressions and break them down. We're going to do unit conversions, but with cubic units this time. And then we're going to do volume with a prism. These will all be on your test. Here we are asked to simplify this expression. Now we can consider a square root term a like term with another square root term if the number or base under the radical is the same. But none of these look at all alike. But we can simplify them and then see if they look alike. Take 18, the square root of 18 for example. How do we get the square root of 18? Well, there's a couple of ways. If you can think of something that multiplies to make 18, that is a square, a perfect square, then you're already on the right road. Let's try that. Just taking the number square root of 18, we know that we can make a factor tree, and that is 2 times 9, and 9 is 3 times 3. And when we have a square root, that means a square is something times itself. So if we find anything times itself, then it can come out from under that radical, but you only need one of those factors, just 1, 3. So in other words, this will come out as a 3, and the 2 is still trapped inside, and it simplifies to 3 square root of 2. Another way we can think of this is square root of 18 is the same thing as the square root of 9 times the square root of 2, right? Because 9 times 2 is 18. Now, we know what the square root of 9 is. The square root of 9 is 3, because 3 times 3 is 9. But 2 doesn't have a square root, so it stays where it is. Those are two ways to think about it. Now, over here, we have this 3 out front, and we have the square root of 18. That 3 needs to stay there. It is multiplied times whatever square root of 18 is. So over on the right, we found that the square root of 18 is really 3 times, square root of 2. So now we have to multiply all of that together. We'll just hold that thought and we'll simplify the next term. The next term is subtracted, and we have the square root of 8. I'm going to make some room over here. Now the square root of 8, we need to find some factors that multiply to make 8. The square root of 8, 8 is 4 times 2. So the square root of 8 is just 2, square root of 2. The square root of 4 is 2, and the other 2 stays under the radical. Another way we can think of this is if we break 8 down, it's 2 times 2 times 2. Whatever I have 2 of can come out of the radical, and that's where we get this first coefficient 2. Now remember, 7 has to be multiplied times all of that. So I have 7 times square root of 8, and over here I found that square root of 8 is the same thing as 2 square root of 2. All right, now we have 3 times the square root of 50. I need to take the square root of 50 and simplify it. I can break 50 down into factors, but if you remember, 2 quarters makes 50 cents. So 2 times 25 is 50. That means the square root of 50 is the same as the square root of 2 times 25. And I can write it as the square root of 25 times the square root of 2. Now I know what the square root of 25 is. It's just the number 5. And then the square root of 2 cannot be simplified, so it just stays under the radical. I come back to my problem. I already wrote my 3 as a coefficient. It's going to be multiplied times whatever square root of 50 is. Well, we found that the square root of 50 is 5 times square root of 2. The last term is the square root of 32. So let's erase and make some room and find that square root of 32. I know, but maybe your brain doesn't go there, that 16 times 2 is 32. But if I didn't know that, I would think, 4 times 8 is 32, and 4 is 2 times 2, and 8 is 2 times 2 times 2. So whatever I have 2 of can come out. I have 2 2's. They can come out as a 2. And I have 2 more 2's, and they can come out as a 2. And this last 2 is stuck under the radical by itself. Now, how does that help me? Well, square root of 32 becomes 2, this 2 that came out times this 2 that came out, with the last 2 stuck under the radical. That's one way of figuring out what the square root of 32 is. Another way of figuring it out is remembering a perfect square, 16 times 2 makes 32. And the square root of 16 is 4, and 2 is as simple as it gets. One other way that you could work this is that you could remember that 4 times 8 is 32, just like we did before. And 4 is a perfect square, so that's awesome. I can use that. The square root of 4 times the square root of 8 is the same as the square root of 32. But 8 is also 4 times 2. So I can rewrite the square root of 8 as another square root of 4 and a square root of 2. So 4 times 4 times 2 makes 32. Now the square root of 4 is 2. The square root of this 4 is 2. And then this last 2 is just stuck under that radical. I still end up with 4 square root of 2. These are some ways that you can get the square root of a weird radical simplified. You find factors that are perfect squares, or you find a factor in a factor that is found 2 times and it can come out as one of those factors. So the square root of 32 is 4 square root of 2. All right, so I simplified each radical. Now I need to simplify my terms. This first term, 3 times 3 times square root of 2, I can write that as 9 square root of 2. The second term, 7 times 2 times square root of 2, 7 times 2 is 14 square root of 2. 3 times 5, 15 square root of 2. And my last one is just 4 square root of 2. Wow, now I have like terms. Every term in this expression is expressed in units of square roots of 2's. I can treat these radicals like they were an x, kind of like 9x minus 14x plus 15x plus 4x. I could think of those square root of 2's as these x's. So I need to add those like terms. Well, all I have to do is add the coefficients. 9 minus 14, that's 9 plus negative 14, that's negative 5, plus 15, that would be positive 10, plus 4 is positive 14 square root of 2. That is the answer simplified. I simplified my roots, found like terms, and combined my like terms. All right, now we have unit multipliers with cubic units. Cubic means if I have cubic miles, that means to the third power. And centimeters, if they're cubic, that's to the third power. Now, how do I get from miles to centimeters? Well, I'm glad you asked. Miles and centimeters don't directly convert, but I know that 5280 feet is in 1 mile, right? And I know that 12 inches is in 1 foot. And I know that 2.54 centimeters is in 1 inch. So I can go from miles to centimeters in a chain reaction, sort of. It's going to take a couple of conversions. They gave me a hint that I'm going to need 9 unit multipliers. That's a lot. I'm going to have to make a long list of fractions. So this will take a minute. I begin with my first number that they give me. Miles cubed. That's 3 of them. That's my given. That's the same as miles times miles times miles. I'm about to make some unit conversion factors, which are fractions. So I'm going to make this a fraction by putting it over the number 1. Now this is not a unit conversion factor. This is not a unit multiplier. This is my given. I'm going to create unit multipliers with these knowns. Now I can put miles in the bottom and feet on top. And that gets rid of 1 of these miles, but I still have 2 of them. So I have to do it again. 5280 feet and 1 mile. That cancels with another mile, but I still have a mile left. So I have to say 5280 feet per mile again. Now that cancels out with my last mile. I have no more miles. All I have are feet times feet times feet, cubic feet. I'm going to get rid of my feet by putting them in the bottom, and inches. I know that they are equal to 12 inches. That gets rid of 1 of those feet. I have to do it again. And that gets rid of another foot. And one more time. Gets rid of my last foot. And now I have cubic inches. All right, so now I need to convert cubic inches to finally cubic centimeters. I can get rid of my inches in the bottom and my centimeters on top, and that cancels 1 of my inches. I do it again, and I cancel another of my inches, and one more time gets rid of all my inches and leaves me with cubic centimeters. Now my inches are gone, and all I have left is centimeter times centimeter times centimeter. I'm going to rewrite my answer as one whole answer, but I'm not going to use my calculator. I understand that you know how to use a calculator. I'm going to write my answer using parentheses that show me that I can multiply these numbers. My miles are gone, so I just have this first number times 5280, and that's multiplied 3 times, so I can put an exponent 3. I can write my 12, and that's written 3 times to multiply, so I can use an exponent. And then 2.54 is multiplied 3 times. And the inches cubed, that's wrong. The centimeters cubed is what my units are left over. All right, do not try and shortcut by making these cubed with your unit multipliers. That will make careless errors, and it will not give you 9 unit multipliers. It looks like I'll have to do one more video for the volume of a prism. So until then, one more video. Thank you. Good luck on your test.